Okay, welcome to another video going through a decision maths question. This time it's an AQA Decision 1 question from a June 2010 paper, and it's question number 8. And we're told that we've got a simple connected graph with 6 vertices. So a connected graph is one where there exists a path from any vertex to any other vertex. And if it's simple, it just means that there's no more than one edge between any two vertices and no loops from a vertex to itself. So with that, for the graph to be connected, each vertex has to have an edge coming out of it. So the smallest value of the degree of a vertex is going to be 1. So the least possible value for a degree is going to be 1. So 1 is smaller than or equal to x. And what about the greatest value of x? Well, the greatest value of x is going to be if the vertex is connected to every other vertex. And if we have 6 vertices, then if we select one vertex, we'll have 5 other vertices. So the greatest degree is going to be 5. This question will be in a B1 for giving 1 and a B1 for giving 5. Okay, question B. And we've got 6 vertices. And they have degree x subtract 2, x subtract 2, x, 2x subtract 4, 2x subtract 4, and 4x subtract 12. So, we're going to try and solve this equation. This problem actually. And we need to find the value of x. So, there's 2 different methods for this. The first method is consider each different degree separately. So we know that x subtract 2 has to be at least 1, and it has to be less than 5. And we can consider x. X has to be at least 1, and at most 5. 2x subtract 4 has to be at least 1, and at most 5. 2 and 4x subtract 12 has to be at least 1, and at most 5. So we can try solving those. We've got 1 is smaller than or equal to x subtract 2 is smaller than or equal to 5. So that gives us x is between 3 and 7 for this one condition. We have 1 is less than or equal to x is less than or equal to 5. We can try 2x subtract 4. And if 2x subtract 4 is between 1 and 5, then 2x is going to be between 5 and 9. So x is between 5 halves and 9 halves. And we can try 4x subtract 12. If 4x subtract 12 is between 1 and 5, then we can add 12 and we're going to get 13 is smaller than or equal to 4x, smaller than or equal to 17, and we can divide by 4. X has to be at least 13 quarters, and at most 17 quarters. And then we can combine our inequalities. X has to be between 1 and 5, so we've got 1, 2, 3, 4, and 5 remaining. If x has to be between 3 and 7, we can't have 1 and we can't have 2. If x has to be between 2.5 and 4.5, we can't have 5. And finally, 13 over 4 is 3 and a quarter, so we can't have 3. 17 over 4 is 4 and a quarter, so we can have 4. And that leaves only the answer 4. Alternatively, you could have actually inputted 1, 2, 3, 4, and 5 into each of these degrees and seen whether they give you a correct solution. And then last but not least, the sum of the degrees. And the sum of the degrees, we get 1, 2, 3, 5, 7, we get 11x. Subtract 2, subtract 2 is -4, -8, -12, and -24. And we know that 11x subtract 24 is even. So if we add 24, we know that 11x is also even, which means that x must be even. So if x is even, that gives us that x subtract 2, which is one of our degrees, has to be greater than 0, so x has to be greater than 2. So if x is greater than 2, but x is less than or equal to 5, and x is even, that only results in x is equal to 4. So mark-wise, you would have got 1 mark for trying a method like this one here, or this one here. So that would have been M1, and then finally you would have got A1 for the answer x is equal to 4. So thank you for watching another video, and for now, goodbye.